Hello everyone. So this is the 19th session of the Advances in Food Analysis, and the topic which we will be covering today is thermogravimetric analysis. Thermogravimetric analysis overview we'll be studying about. So it is a method of thermal analysis in which a mass of a sample is measured over time as the temperature changes. This measurement provides information about physical phenomena such as phase transition, absorption, adsorption and desorption, as well as chemical phenomena including chemisorption, thermal decomposition and solid gas reactions. Thermogravimetric analyzer. Thermogravimetric analysis is conducted on an instrument referred to as thermogravimetric analyzer. A thermogravimetric analyzer continuously measures mass while the temperature of a sample is changed over time. Mass, temperature and time are considered base measurements in thermogravimetric analysis, while many additional measures may be derived from these three base measurements. A typical thermogravimetric analyzer consists of a precision balance with a sample pan located inside the furnace with a programmable control temperature. The temperature is generally increased at constant rate to incur a thermal reaction. The thermal reaction may occur under a variety of atmosphere including ambient air, vacuum, inert gas, oxidizing, reducing gases, corrosive gases, carburizing gases, vapors of liquid or self-generated atmosphere, as well as variety of pressures including a high vacuum, high pressure, constant pressure or a controlled pressure. The thermogravimetric data collected from a thermal reaction is compiled into a plot of mass or initial mass or on a y-axis versus the temperature or x-axis. The types of thermogravimetric analysis are isothermal or static thermogravimetry. In this technique, the sample weight is recorded as a function of time at a constant temperature. Quasi-static thermogravimetry. In this technique, a sample temperature is raised in sequential steps separated by isothermal intervals, during which the sample mass reaches stability before the start of the next temperature ramp. Dynamic thermogravimetry. In this technique, the sample is heated in an environment whose temperature is changed in a linear manner. Applications. The thermal stability. The thermal gravimetric analysis can be used to evaluate the temperature stability of a material in a desired temperature range. If a species is thermally stable, there will be no observed mass change. Negligible mass loss corresponds to little or no slope in the thermogravimetric trace. TGA also gives the upper use temperature of a material. Beyond this temperature, the material will begin to degrade. Thermogravimetric analysis is used in the analysis of polymers. Polymers usually melt before they decompose. Thus, TGA is mainly used to investigate the thermal stability of the polymers. Oxidation and combustion. The simplest material characterization is the residue remaining after reaction. For example, a combustion reaction could be tested by loading a sample into a thermogravimetric analyzer at normal conditions. The thermogravimetric analyzer would cause ion combustion in the sample by heating it beyond its ignition temperature. The resultant TGA curve plotted with the y-axis as percentage of initial masses would show the residue at the final point of the curve. Oxidative mass loss are the most common observable losses in thermogravimetric analysis. Studying the resistance of oxidation in copper alloys is very important. For example, NASA is conducting research on advanced copper alloys for the possible use in combustion engines. However, oxidative degradation can occur in these alloys as copper oxides form in atmosphere as they are rich in oxygen. Resistance to oxidation is very important because NASA wants to be able to reuse shuttle materials. Combustion during thermogravimetric analysis is identifiable by distinct traces made in the TGA thermograms produced. One interesting example occurs with samples of as produced unpurified carbon nanotubes that have large amount of metal catalyzed present. Due to combustion, a TGA trace can deviate from a normal form of well-behaved function. This phenomenon arises from the rapid temperature change. When the weight and temperature are plotted versus time, a dramatical slope change in the first derivative plot is concurrent with the mass loss of the sample and the sudden increase in temperature seen by the thermocouple. Thermogravimetric kinetics may be explored for insight into the reaction mechanism of thermal decomposition involved in the pyrolysis of combustion process of different materials. Though a constant heating is more common, a constant mass loss rate can illuminate specific reaction kinetics. Operation in combination with instrument. The thermogravimetric instrument continuously weights a sample as it is heated to temperatures of up to 2000 degrees Celsius for coupling with FTIR and mass spectrometry. Gas analysis. As the temperature increases, various components of a sample are decomposed and the weight percentage of each resulting mass can be measured. Thermogravimetric analysis is often combined with the other processes or used in conjunction with other analytical methods. For example, TGA is sometimes attached with line with a mass spectrophotometer. So, types of thermogravimetric analysis are isothermal or static thermogravimetry. In this technique, a sample weight is recorded as a function of time at constant temperature. Quasi-state thermogravimetry is a technique in which sample is heated to a constant weight at each of the heating increasing temperatures. Dynamic thermogravimetry is a technique in which sample is heated in an environment whose temperature is changed in a linear manner. So, comparison of thermogravimetric and differential thermal analysis is in TGA. The major difference is in TGA, the weight loss or gain is measured as a function of temperature and time. In differential thermal analysis, the sample and reference is measured as a function of temperature. That's it for the session. Thank you.